Alright friends, welcome. It's Friday again, 10 a.m. Another live coding show. Um, Today I only have till 11-ish, a little before, so it will be quite short show. Um, and then I'm going on holiday, so I'm gonna lay down on the beach and not think about anything for like a week. So next week there will not be a show. Um, when I started this channel, I thought I would provide some form of education with live episodes. I'm thinking it's kind of not it's not going as I would like. I think the tempo is too slow to actually be a very good educational platform. I think it's very fun, but from an educational standpoint, it's a little too slow. So I'm thinking about changing the format a little bit, starting the week after my holiday, and that is to still upload a video at 10 a.m. Central European Time on Fridays, but to have it more of an edited show and not be a live coding show anymore. I'll probably still do live coding, but it will be an ad hoc thing, and I hope to provide more educational value from that. So if you have an opinion about it, drop me a line below. We can discuss, but that's what I'm thinking about now. Since we're short on time, let's see, what shall we talk about? Website is there. You can actually support this channel and the videos that I do. Information about it is on the website. I actually moved the code that we wrote last time into the board itself. That means that what we have now is actually, because I did a small change, I fixed the typo that was causing the orphan lookup to fail. So if you remember, we created this scenario where we have, if we would now make a link, an entanglement, a cycle here between the entanglements, then this board would work correctly, but this sucker here would get orphaned as the pair that it was entangled with is no longer part of a cell. So this would be the only one. So this one should also collapse with the other ones as an implicit collapse, meaning that this one would also become void, and this one would also not have a pair, and thus this one should also collapse. So I fixed that. Let me first show you that it works. There we go. And now we see that the OOX collapses as it used to, but now also the orphans of the O right here, it collapses alongside, and as that means that this one is now gone, this one collapses as well. So if we choose that one, bam, and the board collapses nicely as it should. So that is a very good step. And what did I need to change? Well, let's see, if we go back, I added an enrich paths function, which is used when we actually determine the entire cycle of paths. So that's good. It used the method that we already created. But the new TLCs, the new top level cells, which were these two suckers right here, I created a step to add them to the top level cells list based on their non-existence in the path already. So to prevent the recursion that we saw last time, I had to add a simple filter based on the not existence of the distinct keys of the path with the current new TLC. And there was actually a this was new path. It was correct. I thought it was first. we had the typo right here, which was the new TLCs, which now the add TLCs. So if there's no new cells to add, yeah, as it is a concatenation of the rest cells and the new cells, it will keep looking through and to see if there's any recursions. That means that the step between this cell, these cells, and these cells means that if you look at this orphan, it marks it and then says, well, I marked something in a cell that was not part of the path, so take a look at that cell again, and then it finds this one. So if you make it more elaborate, you will see that if we would have an entire cycle like this, let's move this one like this. So you're playing against each other. You think, almost there, right? Do this, right? And then somebody goes and just creates a cycle between these three. It creates a very long path, and we see that we now can make O in a winning situation. O, O, O. The other path would not be a winning situation, no, because O, O, X, O, O, X, O, O, X. So me as the O player, I would choose this one, bam, and I have a winning situation. So what do we do now? I would like to know if there's a winning situation in the board. And I actually thought of something quite interesting while I was thinking about it yesterday. Let's first save this. The test, the game test at the bottom. I figured out, or I thought about it, and I had the idea that winning, that we could create a I cannot type. There we go. All right, we're back. So I figured we could use partition and then create a new small board on which we can determine if there's a winner. So if we would take this setup right now, it is part of reframe, so we can access the reframe db/appdb, and then we can see what this does. So if I thought the range 9, so it will create 9 cells, and then from that it will map the existence of a cell, and then from there we can take a look at what it does. And I failed miserably. What did I do? AppDB. All right, yeah, I need the board, not the entire AppDB, right? So it's board. Yeah. So now it tells me it is player 0, player 0, player 1, player 1, player 0, player 0, 1, 0, 1. So that means that there's a couple of win scenarios. Either you have a horizontal, and then when it's 1, everything should be a 1, so the sum of it will be 3. If everything is a 0, i.e. not nil, and the sum is 0, then the first player wins. And then we can say take the first, take the second, take the last of each to get the diagonal. So first of that row or last, so we can get the diagonals, and the first, the seconds, and the last will also be win situations. So that gave me some really great input. So I think we can actually make something happen right here. Let's see. So let's grab this code and go into our test scenarios. And let's grab this board def win as the board reframe db/app db. Let's insert that. Bam, there we go. So we have the board itself. Right. There we go. Let's evaluate that. And that means that within the win board, we should now see the same set. Yeah. So. And so we can we probably should first start with the horizontals. Those are easiest. So a win, this is win vertical, right? Let's create a board that is winning in a horizontal way. So let's do this. Right, and now we do this. Bam. Now there should be multiple horizontal wins. Bam. There we go. Def win horizontal yeah, right. And then we do the same thing. We do board reframe.db/appdb, right? cpw, bam, it's in there. All right, so given that we create a simple representation of this board with our partition scheme right here, that means that we can do the multiple, let's see, yeah, there's only 2 diagonals, so that will be fine. So there's we can iterate or loop, see if there's any horizontal rows that are in a winning situation, see if there's any diagonals, and see if there's any right. So let's say Devon win horizontal, simple board. Let's see. Win horizontal, and it probably should return. Should it return? What do we need to know? We need to know which player. Let's just start with which player wins. So either it's a 0 or 1 or nil if there's no no wins scenario, right? So let's first make sure that we get what we expect. There we go. Concrete property. Win horizontal. Evaluate it. Need to evaluate this one probably. Excuse me. It's okay. All right. Yeah, so we have the right representation of a board. So A win on the horizontal line would mean that there's no nils in the line, and then either the sum is 0 or 3, right? So let's first see maybe some nil. First simple board. Let's see what that returns. Yeah. Some. So it is false, but then the last that's also false. Nah, it's not right. Let's see. Contains nil, right? First. No. What is first? Should be a list. No, I made a boo-boo. Let's evaluate this. Let's see. Let's see. It's not doing what I expected it would do. So let's see why that is. Right. Alright, so this is a list of lists. And the first of list of lists is, yeah, so second, 1, and the last, right, and then it's nil, right? Second only has ones, so nil, it's nil. Yeah, this is bad. Not a good idea. Maybe we can use filter, right? Let's see. Filter. No. Next. No, of course. No, right? Second. Should be an empty list. Empty list. Probably not a very good way to do this, but I'll take it for now. Click, 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 click. What is clicking? For row and simple board. Get in row seconds. Right. Now I need my partition, right? There we go. Right. This still gives me the simple board, right? And then the win horizontal. Yes, alright. So that, what we can say here is, so for every row we take a look, filter, so if not empty this, if empty. So if it returns empty, as in it is devoid of nils, then it means the entire row is full. So either the sum is 3 or it is 0 for win situations, and anything in between it is nothing. So if it's not empty, right? PRN win row, PRN no win row. So we should see 2 win rows and 1 no win row, right? Can we use cons B? Would that work with the sum? Close your docs. Con P. Let's take a look what the equals value. Yeah, looks like a plus row. And then I wonder if we can, it's probably, let's see, win 0, right? 3 PRN win 1 row, and else PRN no win row. Wonder if this works. Not entirely what I expected. What is row? No. We could probably just do that map. Yeah. The map plus of 1 1 1 would be 3. No. Closure some elements of list. Reduce, there we go. Good morning. Reduce, right. So see if this does the thing we wanted to do, right? Right. To make sure that. Okay. Right. Beautiful. Reduce for the win. Okay, so this means that we will return a 0. This means that we return a 1, and everything else will return a nil. And if there we go. So 0, 1, 0 will be the outcome. 0, 1, 0, right? So we have the horizontal win situations now. That's beautiful. Alright, so that means that if there's more than one back here, that will be red. There will be a win situation. And now we'll do the diagonals. Keep in mind the time. I have an appointment, so I cannot be diagonal. No. Win diag. Simple board. So what is a diagonal? It's either the first, the second last, and the first, second last. So thinking maybe we can use the same feature that we used in the observables. Second. Right. So if we have take the simple board, we do not need to partition, and it will be a partial of first, second, and last. Win diag. Now we take the boards. We should now see a 1, 0, 1, 0, 0, 1, 0. No. No. Why is this? Because it is not what I expect, and that is due to it being threaded through everything. It's not the same thing. No. Maybe there's something in the Juxt documentation that probably does it on a row level. Takes a set of functions and returns a function that is the juxtaposition of those functions, so it's the combination. The return function takes a variable number of arguments and returns a vector containing the result of applying each function to the arguments left to right. Yeah, so it takes a list and goes, well, I'll do for this one first, then I'll do this one first, this one first. So that would be the juxt of partial prior n, and then it takes a list 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And now of course we need to not do it like this, we need to thread this into it. And I'm missing a, yeah, I'm missing a, and we need to execute it, right? So it returns a function and then we need to apply that function. Map reduce No, we'll do something else. Figure that out later. So with the board, we now we just need to say we have two diagonals. Either it is the 0, 1, 1, 2, and 2, 2, right? Yeah. What happens if we reverse 4, 5, 6, 7, 8, 9. Right. Reverse map of reverse. Yeah, so we could basically use the same. So if we have a diagonal 1, 5, 9, reversing it would be 9, 5, 1. Yeah, 9, 5, 1. Maybe it's a little bit too reversed, right? I'm trying to figure out if there's a way to have one. Yeah. So we can use the map reverse on the list to create a simple function that just looks at 0, 1, 1, 2, and 2, 2. And that would work for both diagonals, right? So let's say let's first make a simple. The first one will be get in a simple board 0, 0, right? And that should be PRNF second last. It's probably a better way to do this, but let's find out. No. Okay. The first of the simple boards. The dog is hearing another dog outside. It's very warm, so I have the window open. So the dog is going. He doesn't like that dog very much. There is a better way to do this, but let's first make our algorithm work and then we can figure out a prettier way. Lots of refactoring needs to happen. Yeah, 0. Is it 0, 0, 0? Nee, time. Yeah, it's 0, and the reverse would be map reverse. Yeah, right. So the situation here now is that this function right here, if we make this a function, definitely win row, it will tell us exactly who wins that row, and if we do win row, right, so this will work here, this will work here, and then win of a list of those, right, we can do that. So there is no winner here, there's no winner on this diagonal, and a 0 and 1 both win this. So that's nice. So what will happen if we so we can use this 1033 still going strong. Add this to the game and toss it below here, and then we have this sucker right here. So the def winning will be a, would we be able to use mapcat to say winning on the boards, right? Let's simple become this, create a simplified version of the board, and then can we map multiple functions on a list? We can map, yeah. All right. So let's say win diag 1 on simple boards, simple win diag 2 on the map reverse simple, and win horizontal on the simple board as well. Yeah, I should actually call the functions as well. Win horizontal, right? Win diag, right? Win diag, right. And that means that we will move these suckers out of the way. There we go. And that now we are left, and we can basically return a list of the wins on the horizontal, the win of the diagonal one, and the win of diagonal 2. And that will be a list of lists, and conforming that, it will either it will allow the front end to see it's either these rows, or it is these, right? And so let's test our theory right here. Let's say we're winning. We have a board, so that's board of the app reframe.db/appdb, and it should give us, right, it tells us there is a list of winners for the horizontals. That's either so this one or this one. If there's no winners on every row, there's a list of nils, and if this diagonal is a winning situation, the second element will be the one who wins that, and the third one that. So let's say this, that we create an event. Let's save our test. Says the thing will start. Events, we take the board events. We have a stacked API, so we have collapsations, so it should be done after the collapse. Let's see, there is my classical board dissociation. So currently there is a switch player when we can do the select path. So if we, let's see, let's move this back, let's reload it. So currently if we would create an entanglement, there we go, the player selects it and the turn switches. That is this switch player going on right here. But we don't want to do that right now. I think that if there is a path to be selected, right, that is this this one right here. So select path is being called right here. So whoop, 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 bam. We do the event select path, and that marks the cell as classical. So this will mark the cells in the board as classical, and then from there we should actually go into a state to see if there's a winning situation. So reframe register event fx. It should probably be an fx, right? Yeah. Then we also need to change this one. Winning, right? And then it's a function which takes the cofx, and we want the db from it, right? And there's no thing that we want to do right here. And then we return not only there's no db, but there will be a dispatch. But for now, let's keep it empty. We can either the game goes into a winning state, and thus it says, hey, player 1 or player 0, you have won, or it will say continue. So the it's either dispatch and one of the dispatches that will happen is the dispatch n. It is a list of and that will now be switch player, list of switch player. So let's add this. The state is still play then as well. So we move that upwards, and Right, there we go. So what we should see now is that after an entanglement is made, the turn switches, and that's it. It's my turn. Bam, switch player. And now the question becomes: is or one of the questions that I have that I do not have clear is that if the player gets to select a path, should it continue on that player's turn or not? I think it's fair to have the player 1 continue as the player 0 was able to select the paths. But opinions may vary. Yeah, so that one does not have to do anything. Well, you can only select a winning state if there is the classicals are done. So I wonder how fast this would be. Because now what we get, there is a point that it says, well, mark something classical and then branch out, do many markings of these cells, and now we need to actually move back. So I think the winning might not be a good thing, but maybe it is a sequential dispatch, i.e. it will always be in it. Well, let's see what happens. So let's introduce our let's say results, and that is game slash winning. Winning gets a board, which is in our DB. And let's see what the results are of this, right? PRN results. And that will also show us if our logic is sound or not. So let's first create a simple cycle. Bam. You get to choose. There's no winners at this point. So let's just keep doing this, and we will keep selecting the scenario. Bam. And we did not do the vertical yet. So now I'm doing this and it will not work. Right, so we still need to do the vertical. So let's do horizontal, diagonal, diagonal, vertical. So we just add it to the back of the list. So that will be fine. So now we need to do a diagonal. So yeah. Bam. I had expected that would be a win scenario, but maybe it is not getting the correct board as it is being processed in this dispatch N right here. Right, that's interesting. Reframe. Dispatch N. Expects the collection, right? There's also a dispatch later. Yeah. I will hack it first, and then there should be a way to go and synchronize between them, or actually have an event that will deal with it. Dispatch. See if that is correct. But maybe it still gets the oh, it's yeah, so that is just enough to say I mark this one as a success. So now we have this yeah, so now we have these results, and now we just we need to figure out if there is a non-nil value. So maybe we can just filter no, not not nil. This probably not work. Actually, we can make this work. Right. What we need to do, the results of game winning. Currently, winning board app now reframe.db app eb gives us a list with a list and two values, but we know that these will be first horizontal, second, third horizontal, so we can flatten this, I think. Right, so we can flatten it. Flatten the list of that, and then we can say what was it? Some one. Yeah. There we go. So now we can use sum to figure out which player won thing. No. Measure list contains value. Of value. Thinking it should be sum, right? Because it is part of the FAQ. For For a bunch of items you can use a larger set. When searching false nil you can use false or nil because it returns x, thus x nil is nil. When searching 2 should be nil and 1 should be found. And 0 should be nil because there's no... Right, but if there is a... But now we need to zip map the items repeat through. Zip map. And would it then be a list of 0, 1, repeat through. Oh. But I want multiple. I would have thought that that would work. Maybe it is because... No, it's not because 0. Member some item series, yes, but I want multiple members, right? Let's see. Every, oh my, rinse true if predicate is logical true. No. Nope. It's probably all points to some, and some. Oh, too bad. No. I need to get going because else I will miss my appointment. Still 64. It will match the first. Ah, that sucks. We will have to leave it for next time. Yeah, so I will figure this out later. And that is in the events, in the board, in the board's events, right? Let's do this, right? Bam. Let's add it to source control so that everybody has it. Determine a winning, determine winning situations. Remember, we still need to do the verticals. All right, Ctrl F. Let's do a release. Let's start it. Live coding 011. All right. So remember, next time I will probably be making a edited video, which is a lot shorter. Bump version. So that there's a better view of a better educational value. Let's finish this. Live coding 11, merge, yes. Release. There we go. Let's merge it. Right. Develop now has the version 11. Now we need to go and make a snapshot for stage it. Stage everything, commit it, version bump. And now we need to check out master. BB master. It has a lot of changes, which is live coding 11. All right, so next week I am off. No show then. Week after I will upload an edited video, probably going through the entire process of getting to the working version. I also have another series planned on security, so that will be fun. It will be like a 5 or 6 episode, also edited videos. It probably will take us all the way through the summer, when on Friday I am not off, as I have my son here. So if you enjoyed it, give it a thumbs up. Give me your thoughts on having the edited video somewhere below here. So I will see you next time. Have a good summer. Bye bye.